In this video, we're going to be looking at some geometric sequences that have missing terms, and we're going to try to find those missing terms. Okay, so it says each of the following is part of a geometric sequence, find the missing terms. It also says assume the ratio is positive in each case, and that is important because we will be using square root property, and normally square root property has a plus or minus on it, but we get to just use the positive case today. Now, there's one thing that we need to talk about before we begin. It's this. Okay, so a couple examples here of changing it from radical notation to exponent notation. Okay, so we have the square root of a is the same thing as a to the 1/2 power. Okay, and we have the square root of a squared is equal to a to the power of 2, but also the 1/2. So the power goes on top, right? Just like the power of this one was a 1, which goes there, and this square root, which has an index of 2, goes on bottom. Okay, so that would make this 2 here and a 2 here, which would make it a. So the square root of a squared is a. Here we have the square root of a cubed, so the 3 goes on top, and the index here is a 2, it's a square root, so that goes on bottom. So you have a to the 3/2. And then another one, we have the square root of a to the 4th, which would be a to the power of 4 divided by 2, which is a to the 2. So we're going to be interchanging a lot of those in these problems. So I wanted to get that out of the way first. All right, let's take a look at the first problem. We've got a 15, 2 blanks, and a 30. Okay, so let's write that down. Okay, so what a geometric sequence means is that in order to get the next number in the sequence, you're going to multiply it by something. And then in order to get the next number in the sequence, you're going to multiply it again by something, and that same something. So when we've got 15 blank blank 30, to get to from the first term to the second term, you need to multiply it by something. We'll call that r. And then you'll multiply it again by r to get this term, and then again by r to get this term. So what it ends up being is 15 times r to the third, which is r times r times r, is equal to the last term. Okay, so to get from the first term to the last term, you multiply by the same number 3 times, which is why this is a cube. Okay, so if we solve this, move the 15 over by dividing, that will be 30 divided by 15, which is 2, so you get r cubed is equal to 2, and if you take the cube root of both sides, you get r is equal to the cube root of 2. So now all we have to do to get from 15 to the second term is multiply 15 times our r. So we're to find the first term, we're going to multiply 15 times r to get our second term. Well, we know that r is this, the cube root of 2, so we get 15 times the cube root of 2. This doesn't look like it can be simplified anymore, so this right here is our, I said first term, I meant second term. Second term, it's this one right here, okay? And let's find our third term. To find our third term, we'll multiply the second term by the r again. So I will multiply 15 times the cube root of 2 times the r, which is cube root of 2. Okay, so since we have 2 cube roots of 2 there, we can bring them together and make it a cube root of 4. So this turns into 15 times the cube root of 2 times 2, which is 4. And that is our third term. Okay, so those are the two missing terms. And if you want to prove that it's right, you want to prove that it gets to the 30, you can go ahead and find the fourth term from the third term. So we have 15 times the cube root of 4, and multiply it by the r one more time, we should get an answer of 30. So let's see if we do. We multiply it by cube root of 2. Since they're both a cube root, you can bring that together and multiply. That makes it 15 times the cube root of 4 times 2 is 8. And we know that the cube root of 8 is 2 because 2 times 2 times 2 equals 8. So this becomes 15 times 2, which is 30. Okay, for our next one, we are starting with 11. We're missing 1, 2, 3 terms, and we have the first and the fifth term. Okay, so in order to get from the first to the fifth, remember we're multiplying because this is a geometric sequence. We multiply 11 times r to get this one, 11 times r squared to get this one, 11 times r cubed to get this one, and 11 times r to the fourth to get this one. Okay, so we'll set up that equation. 11 times r to the fourth equals 1. Okay, so that'll be r to the fourth equals 1 over 11, which will mean r is equal to the fourth root of 1 over 11. Now, in this particular problem, it might be easier to write this as a power instead of as a root. Okay, so we can also write this as r is equal to the fourth root of 1, which is just 1, and then the fourth root, or the fourth root of 11. So that becomes 1 over 11 to the, what's its power? 1, and what's the index out here? 4, so 1 over 4. Okay, so it might be easier to use this one on this particular problem. Let's find out. So to get from the first term to the second term, we've multiplied the first term times r. We've found that, right, first, or actually made that mistake last time, right, second term, first missing term, I guess. So 11 times r, which is 11 times 1 over 11 to the 1/4. Okay, so that's going to be 11 to the 1 over 11 to the 1/4. Now, if you know your power rules, okay, since we have the same base and we're dividing these exponents, you subtract these exponents. So it becomes 11 to the 1 minus 1/4, and 1 minus 1/4 is 3/4, so 11 to the 3/4, which is, if we write it in the correct radical form, it would be the fourth root of 11 cubed. Okay, so the fourth root of 11 cubed. Let's get the third term. And I'm going to deal with it in this form and not this form. Okay, so third term, we multiply this times r, so 11 to the 3 over 4 times r, which is 1 over 11 to the 1 over 4. So we have 11 to the 3 over 4 divided by 11 to the 1 over 4. Again, same base. We subtract the exponents because we're dividing. So to be 11 to the 3 over 4 minus 1 over 4, which is 11 to the 1, or 2/4, which would be 1/2, right? So 3/4 minus 1/4, 2/4, which is 1/2, and that will be square root of 11. Okay, so the square root of 11 is our third term. And now to find our fourth term, I'm going to use this one again instead of the one that's in radical form. So I'll multiply 11 to the 1/2 times 1 over 11 to the 1/4. And that'll give me 11 to the 1/2 divided by 11 to the 1/4, which is 11 to the 1/2 minus 1/4. And what is 1/2 minus 1/4? Well, use the common denominator, it would be 2/4 minus 1/4, so just 1/4. 11 to the 1/4, which is equal to the fourth root of 11. Okay, on this problem, we're missing the first and third term, and we're given the second and fourth term. So we're going to need to work backwards to find this. So if we wanted to find the third term, we would take this term right here and use it to find the third term by multiplying it by r, whatever that r is. But to go backwards, we'll have to divide by the r. Okay, so to go forward, you multiply by the r. To go backwards, you divide by the r. So let's figure out what the r is. So we'll start with this, because that's the first thing that we know. We multiply by r once to get this term, and by r twice to get this term. So it'll be 11r squared, because we multiplied it by r twice to get here, equals 2. So that's r squared is equal to 2 over 11 if you divide both sides by that. And then r squared is equal to, or r is equal to the square root of 2 over 11, which I don't know which, if it's going to be better to write it as powers or radicals. So let's just keep it for now in terms of separate square roots. Okay, we can put those back together at any time. Okay, so let's work backwards first. So in order to go backwards, you need to divide the term by r. So 11 divided by r, and that will be 11 divided by the square root of 2 over the square root of 11. Okay, now if you have a fraction within a fraction, you flip the bottom one and multiply, so it'll become 11 times the square root of 11 over the square root of 2. Now, you can't leave a square root on the bottom, so we can multiply by square root of 2 on top and bottom to make it go away, because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. So this entire thing turns into 2, okay, on the bottom. So the top would turn into 11. We could bring this square root of 2 underneath the radical with the 11 to make this 22. 11 times 2 is 22. So square root of 22 and then divide it by 2. Okay, that's your first term. So 11 square root 22 over 2. Okay, now to find the third term, that was the first. Let's find the third term. We will multiply that same 11 by r to get this one. We divided it to get this one. We'll multiply it to get this one. So it'll be 11r, which is 11 times our r, which is the square root of 2 over the square root of 11. Again, we can't have a radical in the denominator, so I'll multiply it by itself and then also do that on top. So the bottom becomes 11. The top, you bring these two together. 2 times 11 makes square root of 22, and the 11 just sits out front. And then we can go ahead and cancel those 11s, and you get the third term is equal to the square root of 22. Okay, for our last example, it's very similar to the third example. We're missing the first and third. The only difference is these are negative. Okay, so we're going to go about it the same way. The first thing we need to do is find r. So negative 7 times r will give us this one, and negative 7 times r will give us this one. So negative 7r squared times r equals negative 11. So r squared is equal to, let's see, divide the negative 7 over, they both become positive, so 11 over 7. And r is equal to the square root of 11 over 7. Okay, and we can keep it together or keep it separately. Let's go ahead and separate it. So do this and this, okay? And we might even need to go ahead and clean up that denominator on this problem. Maybe, maybe not. Let's go ahead and clean it up. That's a 7, not a 2. So multiply the top and bottom by the square root of 7. So that becomes the square root of 77 over, let's see, square root of 7 times the square root of 7 is just a 7. Okay, so a few different ways of writing this. All right, so looking at the first term, we need to use the second term to go work backwards to get the first term. So we'll divide it by r. So it'll be negative 7 divided by r, which is negative 7 divided by, let's see, let's just use this one. It's cleaned up nicely. So the square root of 77 over 7. Okay, let's see. That one might not be the best one to use. I can see it would leave the square root on bottom, a big square root. So let's not do that. Let's use it in this form, square root of 11 over square root of 7. So let's cancel this. So we'll be equal to negative 7 over r, but now I'm going to use r as this form, which would be the square root of 11 over the square root of 7. Okay, now I can go ahead and flip and multiply, and I'll get negative 7. This one goes to the top, so square root of 7 over square root of 11. And I can clean this up by multiplying the top and bottom by square root of 11. Okay, so the bottom becomes an 11. And then the top, there's a negative 7 there, and then let's bring these two together. 7 times 11 is 77, so square root of 77. There is our first term, negative 7 square root of 77 over 11. Okay, that's the first term. Now let's go for the third term. This was the first. This will be the third. Okay, for the third term, we still use the negative 7. You could use the negative 11 and work backwards, by the way. You could do that, but I find it easier to do the multiplying. So it'll be negative 7 times r to get this next term, which is negative 7 times, let's use this one, see if it works this time better. Okay, so running out of room here. So that's square root of 77 over 7. Okay, and let's see, the 7's cancel out. The negative doesn't, though. So that becomes negative square root of 77, and that is our third term. And that's it.